This video is going to help you learn to write word equations, then transform them to formula equations, and then finally learn how to write a chemical equation that is balanced. Here is an explanation of each type of equation. I would pause the video and write these things down along with their samples. We're going to talk about word equations, and a word equation, we write the reactants and products with words. There's no numbers anywhere. Just take the sentence and translate it into an equation with words. The second one is a formula equation, and what you're going to do is you're going to take each of the words and you are going to translate them into an equation. So you're going to take methane and change that to CH4. You're going to take oxygen and write that as a formula, O2. You're going to take carbon dioxide and write that as a formula, CO2. Then you're going to take water and write that as a formula as H2O. Notice that each of these have the state of matter. So this is water in liquid form, CO2 a gas, oxygen a gas, and methane a gas. So you'll have the formulas and the states of matter. Notice in this example there are no quantities, and this is not a balanced equation. In the last one, it's a chemical equation, and in a chemical equation you basically take this same equation, copy it down again, and this time we have to balance it. And if you remember from physical science, that you balance by putting coefficients in front. So that's why I put these lines here. Each of these lines is a place that you might write a coefficient in order to balance the equation. So in order to balance, you have to have the same number of atoms on the left as you do on the right. That's because of the law of conservation of matter. So if we have one carbon on the left, I look on the other side and I see I have one carbon. So that's the same. I don't need to do anything with that. So then I look at the next letter or atom, element, hydrogen. There's 4 hydrogens right here. So I look on the other side and I see there's only 2 hydrogens right there. So I have to do something to balance that. So I'm going to place a 2 in here. And now I see that I have 2 times 2, 4 hydrogens, and 4 hydrogens, so they're equal. Now I'm going to look at the oxygens. I see there's 2 oxygens right here. But on this side I have 2 oxygens plus 2 more oxygens. So altogether there are 4 oxygens. So I'm going to have to write something in front of the left oxygen and put a 2 in front of there, and that should make my oxygens equal. Before I feel like I'm finished, I need to go through and check each element again. 1 carbon, balanced. 4 hydrogens, 4 hydrogens, that's balanced. Now I look at the oxygens. 2 times 2 is 4 oxygens right here. I have 2 oxygens plus 2 more oxygens right there, 4. It is now balanced. And I have a correctly written balanced equation. It's the formula equation with the states of matter and the proper coefficients to make it balanced. Here's an example that I'm going to do. You can write it down or you can just watch. Alright, it says write the word, formula, and chemical equation for the chemical reaction that occurs when solid sodium oxide is added to water at room temperature and forms solid sodium hydroxide, which is dissolved in water. So, the first thing that we're going to do is write the word equation. I'll put WE for word equation. So we need words. Here it is, solid sodium oxide. So I write sodium oxide, and we're going to add to it water, and it says it forms solid sodium hydroxide. So it says it makes sodium hydroxide. Alright, that's the word equation. Now we're going to take the word equation and change it to a formula equation. So we got to take those words and we got to make them into formulas. So this is where chapter 7 comes in handy. Remember how we wrote sodium oxide? We wrote Na, and it was a 1 plus, and oxygen was a 2 minus. And so we do the crisscross rule and we got Na2O. Now you all have to make sure that you erase that oxidation numbers up there. Don't leave them there. Alright, now we need the state of matter for that. Notice it said solid, so we put a solid right there. And it is going to make water. Well, hopefully you don't need to do the crisscross rule for water, and everybody knows that water is H2O. And if it's at room temperature, we're going to assume that the water is a liquid, and they usually use a script L for liquid. On the other side, we have to write the formula for sodium hydroxide. So I know I have Na, 1 plus, and hydroxide, remember that's from your polyatomic ion list, it's OH, 1 minus. Now we do the crisscross rule, and so we get NaOH. So I'm just going to write that so it looks nicer as NaOH. NaOH. And we need the state of matter for that, and it said dissolved in water. Remember that means aqueous, AQ, aqueous. Alright, so we have the formula equation now complete. So we're ready to choose and write the chemical equation. Alright, so now we're going to write the chemical equation. Remember that the chemical equation is the same as the formula equation, but with it balanced. And remember that the only way to balance it is that you have to put numbers in front of the formula, never between and never at the end. So I'm going to recopy the top, putting lines here. Now you don't have to put the lines if you want to just leave a space for you to do that. That'd be okay, but I put the lines because it helps me remember that that is the only place I'm allowed to add a coefficient. Alright, so I'm ready to do the balancing. So I'm going to start on the left hand side with my NAs, and I see I have 2 NAs right here. So I go over to the other side and I notice there's only 1. So a lot of this is trial and error, so I'm going to try and put a 2 in here. So now I'm going to go to the next letter. Well, you know what? Since I see some O's here and some O's here, I'm going to leave those to the end. I'm going to try just working with the hydrogen now. So there's 2 hydrogens here, and when I look on the other side, I'm like, oh, I have a 2 here. I have 2 hydrogens on the right-hand side. So the hydrogens are now balanced. What I have left to balance now is the oxygen. So I have 1 oxygen here plus another oxygen here. So I have 2 oxygens on the left, and look at that, 2 oxygens on the right. So I think I'm balanced, but before you're done, you should always start over and check. So 2 NAs, 2 NAs. 1 oxygen here plus 1 here, 2 oxygens, 2 oxygens. And lastly, 2 hydrogens, 2 hydrogens. I am finished. I now have a balanced chemical equation with the states of matter. Alright, we're going to do this one together. I would like you to write this down, and I'll take a look at it when we get back in class. So I would like you to first try and write the word equation, and I'll pause a little bit here, and maybe you want to stop the video and go ahead and write down what you believe is the word equation from this paragraph. Alright, so what you should have written looks like this. Hydrazine says it reacts violently with oxygen, so that would be plus oxygen to produce, so that's our arrow, gaseous nitrogen and water. That would be plus water. Alright, there's our word equation. So next I would like you to try to make a good attempt at what a formula equation may look like. I'll pause again and you write it down. So you should have written hydrazine. Well, here's the formula up here, so you didn't have to come up with anything on your own. And it says up there that it's a liquid. And it's going to combine with oxygen. Now, oxygen is tricky. It is always found as a diatomic element, so you have to put a little 2 there. And we'll talk about that in class when we get back together again. Nitrogen is also diatomic, so you needed to write N2 for nitrogen. And both of those are gases, so let's put gas for their states of matter. And then water. Well, if it doesn't say anything different, then we're going to assume that the water is in the form of a liquid at room temperature. There's the formula equation. If you didn't get yours right, fix it now. You might not have known about those diatomic elements. Alright, now we're on the chemical equation. So in the chemical equation, basically all you are doing is copying back the original equation and put the numbers. So I'll go copy it and you go ahead and try to balance by putting in the proper coefficients. Alright, so again, remember that you are comparing elements on both sides. So we compare this nitrogen, and I see 2 here. I also see 2 on the other side. So that means I don't have to do anything to fix the nitrogen. They are balanced. Now I'm going to look at hydrogen. I see I have 4 on this side, but I only have 2 on that side. So what I will try to do is put a 2 here and see if that's going to work out. So now I see I have 4 hydrogens on the left, 4 hydrogens on the right. So now I'll go to oxygen. I see I have 2 oxygens on the left, and now I have 2 oxygens on the right. So it's balanced. I always go through and make sure that the whole thing is balanced one more time. 2 nitrogens, 2 nitrogens. 4 hydrogens, 2 times 2, 4 hydrogens. 2 oxygens, 2 oxygens. Boom, we're done. I'm going to leave you with 3 to try on your own. Notice that this says right here that I would like you to write the word, formula, and chemical equation for all the practice problems on page 290 of your textbook. I will take a look at those, so please have them written on a piece of paper that you can show me when we get back together again. Alright, have a great day off.